sure to like the video and subscribe this channel. Today I will discuss chemistry paper 339701 May June 2024. Let's start. These are the instructions which are very important to read out before starting this paper. Read through the whole method before starting any practical work. Where is appropriate, prepare a table. This is very important. Prepare a table where appropriate and for your result in the space provided. Show the precision of the apparatus you used in the data you record. Show your working and appropriate significant figures in the final answer to each step of your calculations. So let's start first question. You know that this question is of titration. When ammonium compounds are heated with sodium hydroxide or calcium hydroxide, ammonia is liberated. This is information. We know that when any ammonium salt, like if ammonium chloride react with calcium hydroxide to form ammonia gas plus calcium chloride and water. Okay, so this is the exact chemical equation when any ammonium salts react with calcium hydroxide. So this is the ionic equation for this reaction. So Fa1 is prepared by heating 10 centimeter cube. This is Fa1, for example, prepared by aqueous ammonium chloride. So we take aqueous ammonium chloride 10 centimeter cube, and then with 25 centimeter cube of 2 mole per dm cube sodium hydroxide. Add 25 centimeter cube in this beaker sodium hydroxide. The sodium hydroxide is in excess. This is in excess. This is limiting. This is excess. Okay, the sodium hydroxide is in excess. The reaction mixture is cooled and diluted to 250 centimeter cube with distilled water. Take a volumetric flask of 250 centimeter cube and transfer this mixture, sodium hydroxide along with ammonium chloride, in this flask and fill it up till 250 mark. So this is the Fa1 solution. This solution is Fa1 in which sodium hydroxide is in excess. Now you will determine the concentration of aqueous solution of ammonium chloride by titrating the remaining sodium hydroxide from the preparation of Fa1 with a known concentration of sulfuric acid. Now this is this solution to determine we have to find out the concentration of aqueous solution of ammonium chloride by titrating the remaining sodium hydroxide from the preparation of Fa1 with a known concentration of sulfuric acid. So Fa2 is 0.0520 mole per dm cube of sulfuric acid. Fa3 is bromophenol blue indicator. So sodium hydroxide react with sulfuric acid to form sodium sulfate and water. Now Fa2 is solution of sulfuric acid, Fa1 is of ammonium chloride, and add a few drops of Fa3 to the conical flask. This is Fa1 solution. This is Fa1 solution in which ammonium chloride and sodium hydroxide is used in excess. Now fill the burette with Fa2, few drops of Fa3 to the conical flask. Perform a rough titration and record your burette readings in the space below. So this is the table, how to make the table of for rough titration. Always use table to record your reading of rough titration. So first write down final burette reading and final burette reading of Fa1, Fa2. Fa2, this is Fa2, this is Fa2, and this is 27. Initial reading is 0.00, 27.50, and the volume used is 27.50, and each final minus initial, and we get, so volume used is calculated by final burette reading minus VF minus VI. So we get volume used, that is 27.50 centimeter cube. Carry out as many accurate iteration as you think necessary to obtain consistent result. Make sure any recorded results show the precision of your practical work. Record in a suitable form in a space below all your burette reading and the volume of Fa2 added in each accurate iterations. Now draw another table in which you have to record uh, three readings for the titration. Final volume of Fa2 is 25.60, and initial final volume of Fa2 is 0.00, and this is first reading, and this is second reading, and this is third burette reading. So best titration is in which the difference between two readings should be not more than uh, 0.20. So this is 25.50 and 25.40. The difference between is 0.10. So these are the best concordant reading. So these are the marks you are getting. So 6 and 6th and 7th marks is of the difference, if you, the difference between more than 0.30, so, and 0.20. So the supervision, if the supervisor reading writer is of 10 centimeter cube, the difference should be 0.10, 0.150, and 0.250. So this is not more than this. So then you get these 6 and 7 marks. From your accurate titration results, calculate a suitable mean value to use in your calculations. Show clearly how you obtain the mean value. So now we have these two consistent reading, 25.50 and plus 25.40. By dividing 2, this is how to get uh, mean value of the volume used of Fa2. So this is Fa1 is required 25 centimeter cube of Fa1 is Fa1 required 25.45 centimeter cube of Fa2. Fa1 you know that we have taken in flask, conical flask, and Fa2 is in burette, so keep it in mind. So the reading is 25.45. Calculations gives your answers to C2, C3, C4 and C5 to an appropriate number of significant figures. Answer should be in 3 to 4 significant figures. Calculate the amount in mole of sulfuric acid present in the volume of Fa2 in B. So mole is equal to concentration into volume in centimeter cube divided by 1000. So we have volume 25.45 divided by 1000, and we have mole of sulfuric acid is 0. Concentration of Fa2 solution is 0.0520, which is sulfuric acid. So by calculating these values, we have 0.00323 mole of sulfuric acid used. Use your answer C2 to calculate the amount in mole of sodium hydroxide in 25 centimeter cube of Fa1. So we have 2:1 in chemical equation. So by using this mole ratio, we have amount of sodium hydroxide is 0.00 265 mole. Use your answer to C3 and information given to calculate the amount in mole of sodium hydroxide that reacted with ammonium chloride when Fa1 was prepared. Volume ratio mole is equal to, we know that we have mole in 25 centimeter cube is 0.00265, while what would be the mole in 250 centimeter cube volume. So amount of sodium hydroxide reacting with ammonium chloride is equal to 0.0265 minus 0.00265. So this is the amount of sodium hydroxide. Now we have a mole of ammonium chloride. So this is amount of ammonium chloride is 0.000265. So by calculating this mole, amount of sodium hydroxide that reacted with ammonium chloride is 0.0238. Use your answer to C4 and the information given to calculate the concentration in mole per dm cube of ammonium chloride solution used to prepare Fa1. So we have taken 10 centimeter cube of ammonium chloride. So mole is equal to mole. So concentration would be mole over volume. So this is not mole, this is concentration. We know that concentration, how to calculate concentration, mole over volume into 1000. 0.398 are the mole. Sorry, this is not 0. This is, so concentration is equal to, concentration is equal to of ammonium chloride is equal to mole over volume into 1000. We have mole is equal to 0.0238 and volume we use initially, that is 10 centimeter cube of ammonium chloride. So the concentration of ammonium divided by 10 into 1000. So this is how we get 2.38 mole per dm cube. When ammonia gas is prepared by heating one of its salt with calcium hydroxide, it can be dried by passing it through a drying agent. Drying agent for gases include calcium oxide, calcium sulfate, concentrated sulfuric acid, and phosphorus 5 oxide. Select one of these drying agents and suggest why it is not suitable for drying ammonia gas. Concentrated sulfuric acid is not suitable because it reacts with ammonia as ammonia is a base. We know that in this reaction ammonia gas is produced, so which can react with sulfuric acid, so to form ammonium sulfate. So we can't use concentrated sulfuric acid because sulfuric acid is an acid and ammonia is a base. So acid and base can react with each other to form salt. So that's why we concentrated sulfuric acid is not suitable because it reacts with ammonia as ammonium is a base. We can use any base, calcium oxide we can use in this reaction because ammonia is a base and calcium oxide is a base. So but concentrated acid cannot be used in this reaction. Question number 2, a sample of ammonium bromide has been accidentally mixed with another salt. A student suggests that percentage purity of the ammonium bromide can be determined by the measuring the change in temperature when a solution is prepared. The enthalpy change when the sample dissolves in water, delta H, can then be calculated and compared with the uh, literature value for ammonium bromide. You will carry out the students experiment. Fa4 is ammonium bromide mixed with another salt. Method is support the cup into 50 centimeter cube. This is the support the cup in 250. This is the 250 centimeter cube beaker, and we place polystyrene cup in this. So this is how to use the 25 centimeter cube measuring cylinder to transfer 25 centimeter cube distilled first 25 centimeter cube distilled water in this polystyrene cup. Um into the cup, place a thermometer in the now placed thermometer in this polystyrene cup. If necessary, so the bulb of thermometer is fully covered, record the thermometer of the temperature of water in the space for result. Weight the container with Fa4, record the mass, add all Fa4 in the water in the cup. So then Fa4, before after weighing, Fa4 is adding in this cup. Stir the mixture gently so that Fa4 dissolves. Now stir the mixture with thermometer. Okay, this is thermometer, let's say, and stir this mixture with thermometer. Measure and record minimum temperature reached. Now record the temperature, maximum temperature, and when the temperature thermometer on the thermometer, when temperature remain constant, you will check the final temperature. Stir the mixture gently so that Fa4 dissolves. Measure the record the minimum temperature reached. Calculate and record the change in temperature. Weigh the container. After weigh the container with any residual Fa4. Record the mass. Calculate and record the mass of Fa4 added to the cup. So this is how to record your reading. Mass of tube plus ammonium bromide is equal to 44.90 gram. Mass of empty tube, this is also in gram, 29.70 gram. Write down the unit along with the quantity. Mass of tube plus residual ammonium bromide grams is equal to 29.75. Then mass of ammonium bromide is equal to 7.5 gram. This is 29.75 gram. Initial temperature is 16 degrees centigrade, and final temperature when no more change in the temperature is when temperature remain constant on the thermometer. Then note the final temperature. This is 9.5 degrees centigrade. So Q is equal to, calculate the enthalpy change, and we have to change uh, delta T is equal to final temperature minus initial temperature. So this is final temperature, this is sorry, this is initial temperature, and this is final temperature, degree centigrade. So sorry, this temperature should be 19 degrees centigrade, and this should be 9.5. So we have MC, and we have 19 initial temperature. Delta T can be calculated by using initial temperature minus final temperature. So 19 minus 9.5, and we get the 9.5 delta T. So heat capacity is 4.18. This is constant for water. M is the mass, 25 centimeter cube, 25 centimeter cube volume of the water. So volume of water is equal to mass. So always please keep it in mind that volume of water is equal to mass. So 25 centimeter cube is equal to 25 gram. So mass is 25 into 4.18 into 9.5. The answer is energy change is 992.75 joule. When 1 mole of ammonium bromide dissolves in water by enthalpy change, delta H is 16.8 kilojoule per mole. Use the value to calculate the amount in mole of ammonium bromide in the 25 centimeter cube of Fa2 solution Fa4 used in your experiment. Uh, Assume that the enthalpy change when the other salt dissolves in water is 0.0 kilojoule mole inverse 1. So this is 92. So this is 992.75. So we know that the delta H is equal to Q over N, and if we want to find out mole, N is equal to Q over delta H. And in the question it is given delta H is assume delta H is 16.8 kilojoule per mole. So we have 16.8, and this um, 992.75 is in joule. So first convert into kilojoule. 992.75 divided by 1000. So this quantity is now kilojoule. So this is also kilojoule per mole, and this is kilojoule, and the mole is equal to, now mole is equal to 0.992 divided by 16.8 kilojoule by using this relationship delta H is equal to Q over N, while if we have to find out moles, then mole is equal to Q over delta H. So the answer is 0.059. Calculate the mass in grams of ammonium bromide in your sample. If you were unable to calculate the amount of ammonium bromide in B2, then assume it is 2.06 into 10 raised by 2 minus 2 mole. This may not be the correct answer. So we have mole of ammonium bromide 0.05. The answer mass is calculated. We know that mass is calculated by mole into mr. The mr of ammonium bromide is 97.9. So the mass is 0.059 into 97.9 is equal to 5.7 gram. Hence calculate the percentage biomass of ammonium bromide in your sample. 5.7 is the mass of, and the total mass is 15.9 gram into 1000. So this is percentage of ammonium bromide. So original mass of ammonium bromide we are calculating from here. We actual mass is 44.90, and 44.90 minus 29.70. This is equal to 15.9. This is ammonium bromide mass that is actually we were taking. So total mass of ammonium bromide, this is mass of ammonium bromide in sample we are calculating, and this is total mass of ammonium bromide which we have taken actually 15.9. The answer is 35% by mass of ammonium bromide. Another student states that this method is not accurate as the enthalpy change when the other salt dissolves in water could be exothermic. Suggest how the calculated value B4 would change if the other salt dissolves in water. Experiment exothermically. Explain your answer. Temperature decreases is very small, so that's why uh, that's why it is not accurate as the enthalpy change when the other salt dissolves in water could be exothermic. The maximum uncertainty in a single thermometer reading is 0.5. So calculate the maximum percentage error in your temperature change needed in A. We know that we have taken temperature reading two times initial and final, so multiplied by 2 into 0.5 divided by 9.5. 9.5 is the difference of the two readings. So this is actual temperature, and this is two times we have taken temperature reading. So multiply 2 into 0.5 degree centigrade accuracy of the thermometer. So this is in and into 100. This is maximum percentage error, and this is calculating because we are using thermometer two times for to record initial and final reading. So 2 into 0.5 divided by 9.5 into 100, so maximum percentage error is 0.1%. So hope you understand this question. So third question, when we have perform this question, so the observation would be like this. Question number 3 is the qualitative analysis question, and for this question, for each test you should record all your observations in the spaces provided. Examples of observation include color change seen, the formation of any precipitate and its solubility in an excess of the reagent added, the formation of any gas and its identification by a suitable test. You should record clearly at what stage in a test an observation is made. Where no change is observed, you should write no change. Where the reagents are selected for use in a test, the name or correct formula of the element or compound must be given. If any solution is warmed, a boiling tube must be used. If a solid is heated, a hard glass tube must be used. Rinse and reuse test tubes and boiling tubes where possible. No additional test should be attempted. Question number 3, Fa5 is a mixture containing two cations and two anions. Three of the ions are listed in the qualitative um, analysis notes. Test 1, heat a spatula measure of Fa5 in a hard glass test tube. So we have recorded observations like droplets on the water droplets on the walls of the test tube. Purple gas mm, is evolved. Yellow solid on heating. Yellow turned white. White solid change turns yellow on heating and pales on cooling. So these are the list of observation you have we have observed during heating this solid in hard glass test tube, and you are supposed to write down all the observations in this table. Test 2, put a 2 cm depth of dilute nitric acid in a boiling tube. Add a spatula measure of Fa1. So we have seen effervescence of gas which turned lime water milky. It means if lime water turns milky, it means the carbon dioxide gas is present, and this compound is carbonate, metal carbonate. Carry out the following test using a 1 cm depth of Fa6 in a test tube. For each test, record your observation. Test 1, add a 1 cm depth of sodium chloride. When we have added 1 cm depth of sodium chloride, we have seen red brown solution which turns colorless solution when we add when we have added sodium thiosulfate dropwise. Uh, Now test 2, when we have performed this test, the observation would be add aqueous sodium hydroxide for test 2, white precipitate soluble in excess, because first we use few drops and then we use excess. So with this is the observation with few drops and then excess. Add aqueous ammonia. Similarly, first add we have added few drops of ammonia solution, then we used excess. White precipitate soluble in excess. So add a 1 cm depth of aqueous copper 2 sulfate, yellow brown solution is obtained. Add aqueous sodium thiosulfate dropwise until no further change turns to white precipitate. So uh, this for this test, the observation was turned to white precipitates. For test 5, add a few drops of aqueous silver nitrate, then add aqueous ammonia until no further change. So when we have added these reagents, silver nitrate, pale yellow precipitates are formed, and when we further confirm this test by using aqueous ammonia, because this test for halide ions, so if pale yellow precipitate, it will be definitely iodide ion. So for further confirmation, when these precipitates, pale yellow precipitates, remain insoluble, it is confirmed that iodide ions are present in this solution. Fa5 reacts with nitric acid to make Fa6 in test 2 in table 3.1. State a change you would see in one of the observation in table 3.2 if hydrochloric acid had been used to prepare. So yellow precipitates with silver nitrate. Use your observation in A1 and A2, and we have seen that white precipitates dissolves in excess sodium hydroxide as well as in aqueous ammonia. So this is for over here zinc ion is confirmed for zinc ion because zinc remain insoluble with few drops of aqueous sodium hydroxide and aqueous ammonia as well. So zinc ions are there, and this test confirmed that iodide ions are present in the solution. uh, so iodide, and this test confirmed when effervescence of gas which is was formed, which turned lime water milky. This confirmed carbon dioxide carbonate ion. So we have three ions, anions present, and ions are present. One is cation, and two are anions. So formula of ions present are zinc 2 positive, iodide ion, and copper carbonate ion. Fa7, Fa8, and Fa9 are each known to be propane, one all propanol, propanoic acid, or propanone. No two liquids are identical. You will carry out tests to identify samples Fa7, Fa8, and Fa9. So these are our test for organic compounds. Put 1 cm depth in a test tube, add few drops of 2,4-dinitrophenyl hydrazine. So if red precipitates are formed, so it confirm that carbonyl compounds are present. So Fa8 is this is orange red precipitate. Again, carbonyl is confirmed, so no reaction for carboxylic acid. So if we know that when we put a 1 cm depth in a test tube, add a small spatula measure of solid sodium carbonate. So no change with this Fa7, no change with this, but fizzing uh, with this Fa9 solution. So if fizzing, so carbon dioxide is produced, so it is definitely will be carboxylic acid. And if orange precipitates with Fa7, Fa8, one would be propanone, another would be propanol. State what you can deduce from test 1 and 2 in table 3.3 about the functional group present in each Fa7, Fa8. Fa7 and Fa8 is of carbonyl, so we can't identify between propanone and propanol because there is no other test is given over here. So both are carbonyl. Fa7 and Fa8 are carbonyl group, and Fa9 is off. This is a clear test for carboxylic acid because when we add sodium carbonate in the uh, solution, it gives um, fizzing was produced in this test tube. So Fa9 would be carboxyl group. Describe a test to identify Fa7 and Fa8 using the reagent provided. Carry out your test, record your observation and conclusions. Test A, add potassium manganate. Observation, purple to colorless. So it with Fa8 and no change with Fa7, because propanol is not further oxidized, so there is no change with Fa7. So Fa7 will be of ketone and Fa8 will be the propanol. So because propanol is further oxidized to form propanoic acid, so Fa7 is propanol and Fa8 is propanol. Hope you understand this video. So if you like this video, please share this. Thank you.